Hello, ladies and gentlemen. Today we are going to take a look at solving equations and inequalities. So you probably remember most of this from Algebra 1. You also did quite a bit of solving in geometry, so these skills should be pretty fresh in your mind, but it doesn't hurt to review. So for this, you're going to need some notes, a calculator, and of course something to write with. So the first thing I need to focus on is that learning target. So let's make sure at the end of this video today you can say, yes, I remember how to solve multi-step linear equations and inequalities. So the difference between an equation and inequality is one has an equal sign, one has greater thans and less thans. But you know what? The skills required for both of these are the same. It doesn't matter if there's an equal sign or a greater than or a less than or greater than or equal to, less than or equal to. The undoing of operations is the same. So what does it mean to solve then, guys? Well, a lot of times people will say, so do I just solve this problem when the question's really asking to evaluate? Let's be clear what it means to solve. To solve means you're finding the solution to an equation or inequality. Sometimes that solution is x equals 4, y equals 6, 8 equals the w. Whatever it is, we're solving to find that value that makes the equation true or the statement true. So in this case, it could be an equation like you see there on the left, x equals 4, or it could be an inequality where x is greater than 4. Both of these represent solutions. This first one says x is greater or equal to 4, meaning you're only allowed to use 4 as the answer. 4 is the only possible answer for that whole equation. Whereas the one on the right says x is greater than 4. This means all the numbers that are bigger than 4 are valid solutions for the inequality. So sometimes we get a one number answer, sometimes we get a whole lot of numbers as an answer. And so when that happens, we show our answers a little bit differently. So let's take a look at a few examples here. Here's our first solving example. So make sure that you write this one in your notes. We are solving for x. So when you solve this one for x, guys, remember we're trying to get x alone. And we need to first distribute on this side. So we take 3 times the x is 3x, 3 times the 4 is 12. Then I'm going to leave the equal sign. Now let's go distribute on the other side. I'd have negative 2x, and a negative 2 times a negative 5 is positive 10. Now notice where my equal sign is, smack dab in the middle there, right? And on both sides I have x's. I need to get the x's together on one side. So I'm going to go ahead and add 2x here because it's the opposite of a subtracting 2x. That would eliminate those over there, and I'd have 10. And now on the other side, I'd have 3x plus 2x is 5x plus 12. So now if I'm trying to get the x alone, my x's are at least on one side together. Now I can get rid of this 12. I'll go ahead and subtract that 12. So I'd have negative 2 over here and 5x then on the left. Now I still have a 5 in front of my x. That's 5 times x. So to undo that, I will divide by 5. X equals negative 2/5. Now, sometimes you may want to write that as a decimal. I would caution you, just go ahead and leave it as a fraction. Oftentimes in our work, the fraction answers are going to be what's most beneficial for us. So if you can just get in the habit of leaving those answers as fractions, however weird they may be, if they're simplified or reduced down, let's just leave them like that. Okay, you have those fraction capabilities on those scientific calculators, and that makes it really nice. So this equation says, or when we solved it all out, we got to this solution where it's just x equals negative 2/5. That means there's only one answer here. It's only the number negative 2/5 that if I plug it in where the x is here, and I plug it in where the x is here, only the number negative 2/5 makes both of those sides equal. Okay, so let's look at another example of solving an equation. This is another one that has a distributive property in it. Be careful, there's one set of parentheses here, and in front of this set of parentheses, the 2 is the only thing that we distribute. We only distribute what's directly in front of the parenthesis. So I'm going to leave the 3x, the plus sign, and now the 2 times x is 2x, 2 times negative 3 is negative 6, and we have equals to 24. Now notice on this equation, both of my x's here are on the same side of the equal sign already. So I'm just going to combine like terms. 3x plus 2x equals 5x's minus 6 equals 24. And we'll go ahead and undo some operations here. I'm going to add the 6. 5x equals 30. Divide by 5, divide by 5, x equals 6. So this is saying the only number value that works as a solution here is the number 6. So that's a couple equations that you solved, similar to what you solved in Algebra 1. Now let's talk about inequalities. Inequalities have greater thans or less thans in them. And there is a less than sign right there. But don't worry, he works just like an equation. We're still going to undo the operations just like normal. So I see the x's over here. I'm going to add the 2, then to get rid of that. Then I'll have 2/7 x is less than 12. Now you have a 2/7 in front of your x. How in the world do we undo that? Well, remember, to undo a fraction or to get rid of a fraction, you would multiply by the reciprocal. So I'm going to multiply by 7/2. That's just 2/7 flipped over, the reciprocal. And on this side, I'm going to multiply by 7/2. And here's where that fraction button on that scientific calculator you bought, remember that? That scientific calculator has a fraction button. Here's where that fraction button comes in handy, because you can just type in 7/2 times 12, or 12 times 7/2, and that gives you an answer of 42. So notice our answer says x is less than 42. So how many numbers in the world are less than 42? A whole lot, right? So when we want to show the solutions to an inequality, we don't just stop here. We need to show people the answers. It's not like x equals 42, it's obvious. So when there was an inequality, we sketched number lines. So we need to make sure the number 42 is on our number line. So maybe 42 is right here, then 41, then 40, then maybe 43. We'll put 42 on the number line there. And how do we show all the numbers that are less than 42? Well, remember we used open dots and closed dots. We would leave this open because it's not including the number 42. It says x has to be less than 42. So 41.999 works, but not 42. And because of that, we leave this as an open dot. And then I always kind of do a little squiggle here, but you could draw just an arrow. We squiggle or draw an arrow on the side there that represents all the solutions where x is less than 42. So we're going to the left here. Okay, so always on an inequality, we will sketch those solutions on a number line. Let's take a look at another example. This one's called a compound inequality. That's because there's more than one inequality at the same time. This one's rather strange. Again, you did solve some of these in Algebra 1, but notice that there's two symbols here. Okay, it's compound because it has multi-parts. Notice what's in the middle though. This is the 2x plus 4 is in between those two less than symbols. That's the part we're going to focus on solving. So we're going to go ahead and get that x alone just like we normally would. I would subtract 4 here. Now when I go to subtract it from the middle, now notice because this has technically two ends, we also need to subtract it from both ends. So yes, you're going to write -4 3 times. That's okay, we're solving the middle and then we're going to do that same thing on both ends. So that would eliminate the +4 in the middle. We'd have x squared less than, now let's calculate this side, 12 minus 4 is 8. Now let's go calculate the other side. -4 minus 4 more is -8. Now I'm still focused on what's in between the little less than symbols there, okay? And that's a 2x now. So now to undo the 2, I'm going to divide by 2 on both halves, all sides. And here we have 8 divided by 2 is 4, x, and then on the other side, -4. So now the x is alone in the middle there. Now if we were going to read this, you would start by saying -4 is less than x is less than 4. Well, that sounds kind of weird, right? Like, what does that mean? But this is saying that x is in between 4 and -4. That's what that's saying. Okay, it's less than 4, but greater than -4. So when we draw this on the number line, we would want to make sure that we have 4 and -4 on it. So I think I'll number by 2's here. just so I don't have to draw so many little marks. There's my 4, there's my -4 on there. I'm numbering by 2s. You can number the number line however you want. And this is saying x is between 4 and -4. So again, open dots and closed dots, we need to mark on our numbers here. -4 and 4, they're both going to be open. The only time we fill them in is if it's got that little equal to bar underneath, like less than or equal to, greater than or equal to. So this is saying x has to be in between -4 and 4, but it can't actually equal any or either of those numbers. So when we sketch that on the little number line, you may have just drawn a line in between those. I always draw the squiggle there because it's easier to see with my marker here. But that's how we would indicate that solution on the number line. Okay, let's take a look at one more. Last one. This is another type of compound inequality. What makes this one compound is, again, it has multi-parts, steps involved here, and 2 parts, except now they're combined with the word or. So rather than smush them together like that last example where they had 2 less than signs, 2 greater than signs, that does not happen here. It doesn't say choose your favorite and solve that, though. It means you have to solve both parts, and then when we draw our solution on a number line, something special should be happening there. So let's go ahead and solve each one separately. So I'm going to solve this part here. I have 2x minus 6 less than or equal to positive 6. I'll go ahead and add the 6 here. 2x is less than or equal to 12. X then is less than or equal to 6 when you divide by 2. I'm going to write the word or now, and now go over to the other side. I'm going to add the 11, add the 11. 3x is greater than 21. Divide by 3, divide by 3, x is greater than 7. So when we go ahead and draw these on the number line, my 2 numbers I need to make sure I have on the number line here are 6 and 7. So maybe I'll do 5, 6, 7, 8. Okay. Ooh, my pen didn't want to write there. How about that? 8. And now let's mark those numbers appropriately. Let's draw what each part shows. This is saying x is less than or equal to the number 6. So on the number 6, you can fill in the dot because it's or equal to. That means it can be 6. It doesn't have to stop at 5.999. Now, where are all the numbers that are less than or equal to 6? This side. Okay, and now let's go to the other part. X has to be greater than 7. So when I mark the 7, I need to make sure it has an open dot because it's not or equal to. Okay, it can't be 7. It says x has to be just greater than 7. So 7.11111 would be fine. So I'm going to shade or mark all the numbers that are greater than 7. Now notice this is actually saying x has to fall in this region here or this region here. There are 2 regions that give us that answer or give us solutions that would work. And that's where that or comes in. Check out what the way this looks on that graph. They could be here or they could be there. There are 2 regions for those solutions. Okay, so be thinking about that when you're drawing these, when you're sketching on the number line, that these strange things happen when we have these inequalities. And again, we'll be working on this more in class. So I want to thank you for taking a trip down memory lane on this review today, and I want to thank you for taking good notes. See ya!